Hello guys, this is a short video of me just showing what I was doing since the last time, because it's been a long to post a video, and last time I was doing this CEL code. I have not worked on the bizarre underground, and during Christmas holiday I went back and I worked on the casually, without any plans, on the Port 3DO base. You know, that project where I will a lot of the 3D experiments I will run it on an emulation. I will run a PC port basically that emulates some of the cell rendering functions, and also the SDK functions. I must have shown that before. So a lot of these experiments were broken. There were still so many things to fix, and even now there are many things to fix, although there are fewer things. 4BPP sprites work now. A lot of things have been fixed, and on GitHub it was. See, I was doing something on October. I didn't touch this, and then all these days of December, after Christmas, New Year's Eve, I was fixing a lot of things. And there are still few things, and I realized something about this CEL Renderer. Anyway, packed train, okay, I need to see why it doesn't work. Packed radial. Oh, I fixed that yesterday. Some of these fixes don't have to do with the CEL Renderer, but it has to do with code on the PC side or in general. I still have enough problems with the packed sprites. Ha! Hold it a minute. Parallax test. The grass, everything else is good. The grass is not good. How do I... Yeah. The grass should be scrolling, not... So... Sprites. Parallax tests. Parallax tests. Grass still. Pack texture and some offsets. I need to see why. If it's a pack texture, I cannot do cell window. I'm just scrolling it. This is not implement, not important. Now the packs are still heavy. Enough of the packed are fixed. The rest is CPU stuff. So this is fixed. And I even did a lot of work with in the Gecko sprite I implemented a lot of things that were missing on the CEL rendering emulation. I would use this remove them from the found. The LD side LPRS LDPP, which they say from the cell, try to read the palette, read the size, read the flags, and things change in the cell. You might have to move things in the structure for things to work. And that's how it works on the 3DO2. All these tests work on the 3DO, so I had to make it. Because I had sometimes we were talking about it. Someone told me, no. So what happens is, where is it? So this is the struct that you send on the cell struct on the 3DO. But if some flags say, I don't want to use the vectors, it's gonna be sprites. Don't make the extra effort for every individual sprite to read the vectors for scaling, for the two vectors and the third one for polygons. Don't read. If you do that, the 3DO expects, let's say I remove the vector, the 3DO expects that you shorten the struct. It expects that you send this. So when it tries to read with an offset this, it expects to find this. And also pick C, I remove it. There's no palette, there is no. And also I added a function where this pre0 pre1 can be, this is what I did now, can be at the beginning of a bitmap. So you go with the source pointer where the bitmap is and you will find this there. So you could remove entire parts of your struct and make the structs much smaller, which is both good for memory and possibly for speed. But imagine all my CEL renderer was going and saying, okay, give me CEL CCB plut. And this is an offset on the struct, and if I have moved things around, it's not gonna work. So the workaround to emulate all this extra stuff was to probably at this point, also this is the SDK, so it's an extra thing that does it. To have this prepare cell before render cell, where I'm saying it's a bit janky. If you have the plut, then load the thing, else. Now I have the cell state, because the way it works, you have a list of 100 polygons. The first polygon doesn't omit this flag. The first polygon says, please load my palette, load my vectors, load everything. But the rest of the polygon is like, don't load them, get whatever was left back in the state from the first polygon. If the first polygon selected the palette, I'm gonna use whatever is there. So if the CCPL the plut exists, I have this static CCP, I save the plut pointer from the source, and the destination, I also copy that there, else the destination will take it from the previous state. And here I had to do it like that. The user sends draw cell CCB, and I have this prepare cell again study that's like, yeah, do some copies from the original CCB to the one, so that I don't have to reduce the struct, because outside on CEL Renderer it says get me the offset to the source pointer, the plut pointer to the HD, and this will always be +8, +16, plus, so it's gonna be wrong. unless I made a replica of the original struct using the stored values from the previous state. So I made this whole thing. I do ldplut. Even that I haven't tested, and it works pretty well. And this is, we had a discussion. I said in the 3DO Discord that when I remove those flags, I have to concatenate my struct. I have in my code, not here, which is part of the emulation, but here, I have to do a memu copy. Now this is not very optimized for the memory, of course. I have to create my own struct, but I have to copy the later pre0 which I want back. I don't remember what I'm doing. Anyway, I have to alter, so the struct is not gonna be, not the data. This CCP pre could be here, for example. It could be here, depending. So things will be missing and I will squeeze things. Now normally I should have a struct my CCB, sprite CCB, polygon CCB. Also those are never needed, and on Bizarro Underground I have removed them. Also on Bizarro Underground I tried to do that. I could remove those and put them on the beginning of the bitmap, but the problem is I'm creating the subdivided polygons, I'm creating the level of detail polygons where I go and read them and create different values. So it's a bit complicated. I tried to do it and I got into serious issues. I have, but I think on the Bizarre Underground, if I do the same with the pre, if I remove them from the struct, I might gain a bit of memory. Anyway, and this whole thing is new and it's really brilliant and it works. I think I even no, sorry. Look, I also remove CCB pre now. Okay, yeah, destination pointer. Oh, the destination pointer is no, it must be the source pointer, and these are my bitmap data. So I do this +4. So I give some space. This 16 will 8 bytes, and I copy the pre0 and pre1 to the destination point. So I even do the CCB pre now, and that works on the real 3DO. I even, okay, actually, logic. I tried that to see about the speed in the real video. Interesting. I say 72 now, wait a minute. Maybe I misremember. It says now it's 80 FPS when VSync is off. And I say by 90, yeah. So why is it 80? I'm having many numbers here. So recently I tried the old version, and I was getting, today on my 3DO I was getting 72 FPS. And then I'm implementing, I didn't implement, this is new, the CCB pre, the copy the pre0 pre1 in the beginning of the source bitmap is a new thing. I put it there and now it goes to 80. However, I said in this old post, I said I was getting 80 FPS. No, if I run this old test, I have the old version and the new, I was getting 72 now. I'm confused with the numbers. I confuse myself. So I got even more with that, and I implemented here, and then I tried it on Real 3D. So this thing worked. Ah, yeah. I forgot about it. We had a discussion on the Discord from some emulator programmer who says, no, you shouldn't concatenate this. This is not how it works. But this is how it works on the Real 3DO too. This is how it works. If you enable the flag, in my current test, this is how. If it didn't work, the 3DO would crash. I have to pack the things. So the CEL Renderer goes, what's the next value after Y pose? Oh, the flag say that you disabled the vectors and the palette and everything. So it has to be. So when it searches for CCB pre, it expects it here. It doesn't expect it. It expects it here, where this used to be. And that's. But also the pre-0 CCB pre, that's a different thing. With the CCB pre flag, as I said, you can say, actually if you remove the CCB pre, it's the opposite. If this doesn't exist, it will expect it, and I even do the same thing. I always have the dummy, the destination cell, so that outside on the CEL renderer the pointers are the same. So I copy from the base of the bitmap data, where the first 8 bytes are not the bitmap data, but they are the pre0 pre1, I copy them to the destination on the system. So this destination is always a dummy final cell, that is always the whole thing. It is not truncated, it is not reduced. But I know that the source one might be reduced depending on the flags and... Anyway, I was talking too much about this. I was doing things like that. And this whole thing works now. The background layers used to work. The transparent stuff, no, the packed sprites, these are all packed. These are all packed with the packer. And here I also had some problem initially. It kinda worked. Of course the grass still fails for some reason. But in those grades behind, where is those grades, some of the pixel would be transparent. They happen to be black. I had some problem with the transparency. The thing is, you can either... I had to make, it's a bit of a hack. Unpacked pixel, extra info. Now that gives me an idea about another thing I want to do. I have to keep track in an extra. Now the unpacked source is the... I read the packed data line by line and I unpack them here and then I send them to the unpacked renderer. And I have to have this discard pixel because the packed data have an extra information that now if the command I set it to 0, I have to put something. Now if the command is pack repeat, If it's packed literal, I have to read pixel by pixel the data. If it's repeated, it's the same value repeated. But there is the case that it might be packed transparent. So if you come here, it's not literal. It can either be a repeat. If it's not repeat, it's transparent. And now there is information that says the next 20 pixels are transparent. You have to skip them. But however, I don't skip them. I'm not doing the rendering here. This thing in the decode line, if it's packed, you are giving the source to unpack, and you get back the unpacked source, which is another array with a line of pixels. And I'm gonna get it. Now I cast it to 32 bits because I'm doing some reading 4 pixels at one or 2 pixels at one. However, I've recently found a problem with this approach. Obviously, you might have textures that are not divided, so I have to do either DAF's divide or handle differently. Do it one by one. And now this unpack source now, so if it's not packed, it's gonna get the source whatever it was. I also have the LR form. I did the feedback too. I did the, if the texture is a videoram up and down pixel. So if it's, I did a lot of things that were missing. So the unpacking is an extra. So I'm not unpacking and rendering directly. I'm unpacking to the unpacked line so that the regular renderer, the unpacked renderer, okay, if it's raw, it's not palletized. Go right. Else you need a palette, and the palette is a lookup table. I've done the 1 bit, 2 bit, 4 bit, 8 bit. Oh my god, this is a hack because I struggle with that. Now the problem is I was unpacking to this unpacked source, which is 16-bit. Initially I wanted to use the 16th bit, the last bit. The last bit on the left. It's usually not used, but sometimes it's used. And it's not a good idea. In the future, if I'm going to implement more. So I had to have an extra array among the, for special things about the pixel. And now on, it's the discard pixel. I had to say, I'm repeating for different bit depths. It might be junky. I had to say, okay, the destination, which is the unpacked source, put the pixel. If it's literal, read the next value. If it's repeat, you will read the value once. The transparency is 0, the transp. However, I put it here discard pixel. So if it's transparent, it will be that. But if it's repeat, it's gonna be 0. And for both of them, okay, write the same value and write the transparent. Now, you could say if it's transparent, I shouldn't also write the value. There's no point because it's gonna be transparent. Now this info, so it's like I'm also marking with extra information if a pixel has to be skipped. And now I come here to the final rendering and I say, okay, get me the bitmap line. The bitmap line is the destination where I want to write. Is it? Huh. maybe. And I also want to, so there is an extra, the unpacked source can be 8-bit, 4-bit, whatever. But the destination is a 16-bit, always 16-bit. There is a lot of passes, but okay. It helped me organize some things and put them together. So so the bitmap line is I made it 32-bit, even if the pixels are 16-bit. And one reason is I want to have a final value for the rendering. It will take the 16-bit, 15-bit for the color, but I also order the transparent info so that later on I call it color info now. I will end with the discard pixel and I say, okay, if this is not true, render the pixel, else skip it. And now I do it for the text cell, but if it goes to the pixel processor render, which is I have a case so that I don't always do the micro texels where if I figure out that the cell vectors are such that are a sprite, one pixel, one value, and it's not scaled or even rotated, which I could improve and say if the vectors are smaller than something, if the rendering is gonna be pixels anyway. So I'm rendering this one, and it ends up calling the pixel procedure, but now it's a regular per pixel loop. There is a lot. Else it's gonna go to the text cell. It's gonna do something. Is point inside code for its text cell and so on. And the pixel processing, I'm so proud of this whole thing, but there are some issues I have to solve. I have an optimization that here is the bits for transparency, blending, everything. It's doing the whole thing. Source and destination, different sources, different destination. And it might go here if the color after the calculation comes to be 0. You don't just go and say, okay, the source color is 0. You might add the color to something and then end up being not 0. Maybe subtract. I guess if you added it 0 it's gonna be, but you might do some other, maybe the subtract or the exclusive or thing. So I still do it at the end after the calculation for the color. This is all the blending with all these flags are from the 3DO API for the various modes. I don't think I implemented everything. I don't have the EMV bits and a lot of other stuff. But I implemented everything I have used over. So I'm still checking if another flag says I have this cell render info that I prepared in the beginning of the cell. Is it a Maria render for a DOS? Is it transparent GB0? Is it opaque? And because a lot of sprite might never do any calculation with the background or with themselves, say themselves, add their color to themselves and divide. For now, I have this other optimization. So there are some cases where some things are right direct to the color, don't do any. And I have this decode pixie info. I have done the P mode 0, P mode 1 for the pixie has 16-bit upper and lower. It could have two rendering mode. And this is the default value that most thing, if you create a new cell and you don't and it's a regular sprite without blending, without shading, most the default value is 1f00, which might be something like source multiplied by 8 and then divide by 8. But that's the default. Now you could say that I could improve it, that someone might do this or might do this or even this. I don't remember the equation. I'll figure it out myself. But the standard, the default value is this, and most cells that come with this. Most games with regular sprites that don't do any color operations extra, they end up being opaque. You read the texture, you write it. So that's another optimization I did. Let's generate info. I could generate some info based on the vector lengths of a cell. That this is gonna be 1 pixel or less. The textures are 1 pixel or less. So render pixels. Anyway, there's so many things I diverted here. Now, most of these tests, these are just software rendering. All of these are software rendering. If I fix something, in this one I fix something with endianess, for example. And I must have shown this. In this one I say, it was more, because the software render effect worked on 32 bits and was doing tricks. And now my make files for the 3DO, they also define big endian and also project 3DO, because here on the PC port I might say if it's not big endian or if it's not project 3DO, I might want to do something extra only for the PC. And this one I fixed, but it was purely the software on the experiment. It wasn't on the CEL Renderer. That's also, these are all software renders. These were okay. Now this works. It had the wrong colors, but again, there are some pixels, some wrong pixels. Again, it was the flea animator. It was the endianess on the PC against the 3DO. It wasn't. Now this is not correct. It blends, but it should not blend the same value. It blends very low. I've never used the same V bits for any actual thing. This is how it started. I did this recent test and I wanted to port. Ray was challenging me, like, can you do ray tracing on the 3D? Now I did diffuse spheres. There's no reflection, no shadow. It's very simple. And even that thing per pixel, with I wrote a fixed point, full fixed point integer. I made a lot of lookup tables and other things to avoid square root, avoid divisions, and I'm still doing some multiplication and a lot of stuff. And that's expected because on a I started doing this on a 386 PC. Like, I think if I put maybe I'll put the 486. This is where this started. Let's put the Pentium. On the 386, I might get similar speed. Okay, 1 FPS, but this is double the resolution. So that's something I wanted to do since a long time. Try to make a fixed point ray tracer and see how it goes. and then work from up there. I might work in the future in this. I might try to do reflection. I might. I was doing even subdivision, like ray tracing every 4 pixels, and if it hits the same object, then interpolate things, and not ray tracing in between pixels. Else go on 2 by 2 and then 1. And there are still things to optimize, but I did it as an example. Then I thought it would be cool to make it run on cube, but I wanted the cube to rotate smooth, because if I did it in a way so that I'm breaking the ray tracing into pieces. I'm not ray tracing a whole picture and then going to the main loop and set it to the cube, and then, if you get me. So if I go, also I used to have the experiment studio. I stopped. I did some comment there, but I moved the. I had also this port 3DO base with all the 2 tutorials of the lessons I never finished. But now I also make it so that I can also build the 3DO stuff from there. I moved some things. I refactored. I moved some things so that I don't I don't make changes on the experiment 3DO, which is still public. I don't make changes and then commit and then copy the changes on the port 3DO base and commit. I unified them into one, which means I don't update the experiment 3DO, but it's public. So okay, the speed is normal. So the thing is, I'm gradually updating, and then when one image is finished, then I set the texture pointer to the cube, so that the regular frame, the cube rotation and everything is smooth. And you see it, okay, you will see. You see how it started filling this pattern. It had garbage in memory. Yeah, because if I decide to say, you know what, so this is something that I'm passing update piece index when I'm ray tracing. I'm saying render few lines, render the one piece, the next piece, the next piece. Now, because it's a header file, I need to. And the reason I did it is because if I was expecting the ray tracing frame to fully and then pass it to the texture and then rotate the cube and everything, it's gonna make everything slow. It's not gonna look very cool. I guess that's the real speed ray tracing. In the texture is smaller. It's 128 by 128. It's not 320 by 240, so it's a bit smaller. And we are getting 4 frames per second for a smaller one. Real-time ray tracing, but not very, no reflection yet. Reflection will kill it more. I might implement it in the future. I need to change a lot. So that's why I have this breaking into pieces. And in the future I want to see the 3DO. I know, look, I'm a graphics programmer. I know they have threads, create thread, create semaphore. They have things that have to do with running things into threads. Here's tasks thread. I need to understand these things. I don't know much about how these things work. And there are examples. Okay, cool. In fact, I might already use threads on the sound player because I can see that. I got some code that plays music from the CD audio from another project. It works, and I just made it, and it's also creating a thread. Priorities. So it would be cool. The way I'm doing it, you know, I'm doing a little bit of ray tracing piece. You see, updating, blah 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 blah. It goes piece 0, piece 1, piece 2, piece 3, and when it reaches, I do the +1 beforehand. Okay, starting from 0. When it reaches, when it finishes the frame, then this is gonna go and set the texture source pointer to the buff to render. The buff to render, I might have created 2 textures. Cube text, init textures, number of textures, the last value 2, so that I double buffer. And the message you can make in my mesh engine a texture pointer that points in a series of, you can have 10 texture and change the index, and this might update the CEL source pointer and a lot of other things. I have some cool stuff like that from the past. And I flip-flop the buffer to render. So I want to be showing the previous texture while slowly ray tracing on the next one, so that the whole loop doesn't wait. Now it would be cool to, as an exercise, to understand the threads and the tasks and all that stuff, and it would be cool and try to understand this thing and make it that way, make it in a different way. Or maybe, yeah, I can make a thread run, and when it finishes, I just don't know how to split it so that it's optimal. Should I split it 16 parts, 8 parts, 32 parts? It changes. I found a sweet spot with that one. And yeah, that was the cool thing. This is the one that made me, let's port it on the PC, because also maybe there were some bugs and I wanted. This has helped me debugging, because sometimes I find something that crashes. Oh yeah, we have seen because now I'm gonna have to, okay, let's do this. Let's set a starter project. It was hard to organize this here. This always goes. I also emulate the mouse. I'm using the mouse. The Maria pixels. Now, these are software rendered. This had issues with the palette. It was an endianess thing. It wasn't a CEL Renderer thing necessarily. Okay, and that's another one. Those are obviously very slow on the real 3D. Now, the one that still needs work is now. These are the unpacked. So unpacked, and you see packed, unpacked. I switch now. When I switch packed, you see the same thing, but the packed version of the texture and everything works. It used to break. I used to get dirty pixel crashes, everything. And now this is for 4-bit, 8-bit, 16-bit. However, this still doesn't work. I will see why. This finally works, and I had a bug that wasn't related to it was stupid. It was a CPU bug. So I'm making this. This really is not a software render. This really is a lot of cell textures with some areas transparent. They are all packed, one on top of each other. Some areas transparent. They might be concentric circles with the outside pixel transparent. So I rotate many cells that are on top of each other to create this effect. I had this idea how to do it without software rendering, but with some cell tricks. This is slower, and those are suffering a bit on the 3D because there are many, even if they are packed textures. Oh, and that I have to see why it crashes. You know, sometimes I found crashes that didn't happen on the real 3DO. And now this is the recent one that I still don't know why it works. The packed engine still have issues. These are all working very nicely. My whole 3D engine, everything. Was an example with. Maybe I have to do it fast. Very nice. Now, this is broken because I changed something on the software engine. In some of the mode, maybe the 8-bit, I changed something. I was working. So this has nothing. This has to do with my code. It's not a problem of the. It is as bad in the real thing. Now the 3D. Now everything worked. The stars were missing. I don't remember what I did to fix it. Again, it might have been not my render not the hardware cell renderer, but something on the CPU side. Something stupid. The skybox, the colors were wrong. I see some pixels, but maybe it's the same. I don't claim my polygon cell engine to be pixel by pixel perfect, the same as the actual 3DO. There has to be differences. The pattern now they go there because it's very fast. I'm on debug mode even. However, this is suffering on debug mode. Why? Or in general, without necessarily doing more. And this finally works with proper colors. This is very slow on the 3DO because it's reading 3 animations from the CD-ROM at the same time. And the feedback. The feedback is cool because it was the. It took me some time to hard and soft software working. This is the render to texture thing. Render in a frame buffer, read the frame buffer as texture, and render back. This used to not work. Those didn't work. Now they work. They also use the feedback render to texture. But this is the Maria. These textures are 1 bit per pixel, and I simply had to implement the 1 bit per pixel. Oh, I found bugs. This mosaic effect, I made some horrible bug that happened to work on the 3DO, but here it created horrible. The bit flags I was manipulating for the width and height in pixels from the feedback texture, as it changes, I did a mistake and I wasn't cleaning with a mask, and the numbers became enormous. And now that happened to work on the. So only when it does the mosaic effect, especially when it zooms too much, it was wrong, and I figured it out, and that might have improved a bit the speed when you do the mosaic, but it's still not 60 frames. And that's also based on the feedback textures. I'm rendering cubes in time little cubes in the back buffer, one after the other, and I'm reading previous data line per line on different timings to create this slime. It's like they used to do it on the Amiga, I guess, or something. So the feedback is, it's good that they worked. It's only the pack. I still have issues with the pack. I solved a lot of things and I still have issues. And I found bug. It's when you port, you can debug. Okay, the recent thing I did, remember 3Dendro. I'm working now on porting that too. I've ported it, but there are bugs. There are things that work, things that don't work. And it's good because it might help me improve the CEL Renderer emulation engine. So this thing works. It helps me find some horrible bugs I never noticed by porting it on Visual Studio here on PC. There were some compiler warnings that I had something stupid. Now this one, I need to see what happens with the color. And do you see the artifact? The artifacts are not exactly wrong. They are wrong, but there's a reason. And the reason is that when I do alpha blending, there is overlap of text. I didn't have a way which the 3DO has, so that if you do enable, one pixel during rendering blends with the background, and then the other one might be on the same pixel. I have to use, okay, on the right side, when this feedback thing came, there was some wrong stuff. I need to see that. The colors, it must be some endianess thing, and I will tell you something about endianess I just realized. I only realized it now. So the tunnel. Many things are broken here. Okay, the mosaic happened. This jumped. The letters are wrong. The letters are wrong. I know. And there are some black pixels. There was a blob that was blended with the background. And this tunnel is just a big background that is scrolling, and there is palette cycling for the movement. This is an illusion. The tunnel movement is an illusion. It's not real text mapping. I know why the letters. I have broken the letters in very small pixel widths. I know why. Oh, and the blending, something is, yeah. I do know why. Now, also you noticed another thing I haven't emulated is the music. Because I'm not emulating the music. I could put an AIFF player for this, at least for now, but this is not the true emulation. The music is AIFF. That sounded very loud. This is the standard format for CD audio here. I could, just for a port, I could put, it's not gonna be a true emulation of the 3DO, how is it called, the DSP for audio and so on and all that stuff. But if you just want to make a port without caring about precision in emulation, it would be that. So I noticed the blending. I think I will need to go with what I started. I have this thing to mark only for the packed. But everything goes in the unpacked pixel. This is used even if your texture is not packed. Or is it? Okay, I guess I don't do this work that is a lot of memory copy per line. But I can use that. 32 bits, there is enough space. In the future, if I do the pixel processing and it's not opaque, but the source, and maybe I'm doing that, maybe not, is the video RAM, whether it's source 1 or source 2. So if there is ever an operation where the cell color will be added, subtracted, whatever, to the video RAM, because when you scale down cells, when you do, even when we scale in, the text cells might be overlapping a bit. And you will have pixels blended, more pixels blended up. And in order to solve it now, I think I will have to brute force it. And if I'm ever blending, I have to maybe also pass the other array and this one, and add some extra information that says this pixel from this polygon, I will do it per polygon. And my idea is to do an increasing number, like I will say something poly blend ID. It will start from 0 and then I will be okay. I render, no, for the first polygon, maybe it will start from 1. Every pixel covered by the, as I'm rendering, I'm going to also set this unpacked value with that one. But I might have to OR this with whatever it is because there might be the packed. I don't want to delete the transparent information of the discard. Also, I might say, okay, this pixel is discarded. It doesn't even go here if it's discarded. So if I ever have to blend and write, I can say, I might even skip the whole thing. I might say, oh, this pixel is already rendered. It's already blended with the background, so don't blend it again and multiply the color more times. So every pixel covered, and the idea is kinda like a stencil index. The next polygon, because you're gonna go, okay, the next polygon has ID 2, the next polygon has ID 3, because I don't want to go and delete from the previous polygon that covered the area, delete the index from this big array, because I don't want to write the next polygon and say, oh, these pixels are already covered. The new polygon that's gonna be written is gonna render, blend, and so on. It's just that I don't want to blend its own pixel, so I will have to check if the ID I'm blending a pixel is already covered. It must be mine, so don't blend twice. And I was reading I need to find that. I was even reading the patents. I found some patents, and I was curious how the hardware works, how the CEL Renderer. And there was a mention that they are marking pixels that are already for the current polygon blended with the background. They are marking them somehow, so that if there is overlapping pixels, it's not gonna blend twice. However, there are some special cases where you still see blending twice. But I read somewhere that they do this. It's not perfect because I know counterexamples where there are blending artifacts of the same text cell overlap, but I think there is a different reason for that. But I have to do that. I have to do that, else those things will look like that. Horrible, horrible blending artifacts. As they zoom out, those sprites are zoom out. If they zoom in, I notice there are blending artifacts even on Bizarre Underground. On the texels, for example, I don't have it here. And so that will be useful. I have to brute force it. That will be useful to make the blend not overbleed the colors. I don't know if I wanted to say something else. Yeah, I even have the needs frame buff, if at least one of the two sources are frame buff. So I'm already in decode pixie info. I'm already storing. I already know. I don't use that yet. Interesting. So I have stored that, but I ended up not using it yet. But this is what I need. I already have it. Because here I always do everything. So even if I added that, I didn't add it for something that I was needing. But now I need it and I have it, which is great. Which I can say if it needs frame buffer, maybe even here, if it needs frame buffer. Now if it's 0, it's a transparent, the transparent RGB. Uh, this is another thing. The CCB BGND, this is the flag. If this flag is enabled, it says I'm a background, I'm not a pixel from a spy, I'm a background. So RGB00 must render, must replace the pixel. But actually no, yeah. But if I'm missing, RGB0 must be transparent. You have to handle this transparent. And the funny thing is, there is more. If you want to have the complete cell, there is more. There is more. This is how complicated it is sometimes. There is more because this is the BGND. It's a CCB underscore BGND on the. I'm using the things as they are in the header file. Sometimes in some of my examples I was using the no BLK, which means oh my god, it's even opposite. This says no black, but it says if no black is on, then RGB0 is gonna be RGB0. So the name of the flag is opposite to the meaning in the hardware. This is ridiculous. If this is missing, it says if RGB is 0, write it as 100. Now is this red, green, blue? I thought it was the blue channel. What is it? So in some of my old experiments, I didn't want transparent, I would use this one instead of this one. But now I use this one. But I have to emulate this one too. It shouldn't be. Oh my god! Imagine I have to go to the place I'm rendering and I'm saying if it's 0, make it 1. This must be RGB. I need to see that. I might have done the PO. I will implement you. I have implemented Pixar. I don't have it. I use Pixar for the menus on the other. The Maria is implement. This has to do with the two cell engines doing odd and even rows. I could use multicore to implement it for the lols. this is a bit dumb and not even emulators are emulating it. Do I do I implement the clockwiseness, man? Do I even do the clock? Maybe I don't. Super click in this has to do with speed. We don't care. And also, if you go to the preambles, there are some junk. Like this one. If some bits in the color channel is missing, it's gonna get it from the other place. There was something. Set the value of the incoming and code the blue least significant bit. So there are some functions that said the lowest bit of blue, use this instead of that and do something different. So you understand? I don't use the. Maybe there is again. There is more. These bits also play a role in the frame buffer and a lot of. This is way more. The most basic things are here, but to realize how complicated the CEL renderer becomes. And now, finally, I realized something. I need to finish with. I realized that I was passing the changes to bizarre undergrounds. I was doing the changes to the CEL renderer. Here I also have the dummy one. It's kind of different. I was doing something here, and initially, when you start, there is the menu. Initially, after doing some fixes on the CEL renderer, and I ported the changes here in Bizarro also. Let me find it, the 16-bit. And here, initially, the 16-bit unpacked was like that. And I'm like, what happened to the colors? Here it's fine. And actually, I have a theory also. I made a mistake. I'm curious about that. It used to work. No, it doesn't work. I don't know why it worked before, but things have changed. Zero? Do you think it's zero? Of course not. For some reason, this thing used to work, and I didn't have to do this endian flip. So when I have the packed data and I unpack, you have the big endian from the 3D or the big endianness of the only for the 16-bit data, which maybe it's something I also did here, maybe I didn't do it. I didn't do it here on the unpacked. Here is the unpacked. (16-bit). And don't do it for reasons. I know why I don't do it there. Here the data is packed and I did this in there. I don't do it here because in most of my stuff I have this CEL stuff, the CEL data. Some of them are unpacked and I used load CEL, which I emulated, and actually I even got code from the It's on the SDK. Now again, the SDK is incomplete and it will always be incomplete because I emulate only the things that I use. In CEL utils, if you see endian, I do endian flips for the when I parse CEL, load CEL, the CCB flags. I correct pal endianness, correct CEL data endianness, and so on. So I load. I also have clone CEL now. Load CEL. Some of the code I got it from the. I copied it from the 3DO side, from the SDK, and only changed few names. I have commented out this diagnosis because I would have to implement. That's not good. This modify magic cell might be needed by some things. So it's a bit of a hack. Now this whole thing is good for a port, but I realized something. I shouldn't flip all this data because this data, as you read them, are the way. That's what I think I'm doing the mistake. The way they are coming from the 3DO. And I think now my CEL renderer, the way it's rendering everything. Unpack, shift those RGB like this and right and so on for the thing, or render direct. The way it's rendering, this is what you will see. This is visually the same. But if I was to compare byte by byte the 3DO Vidoran with this one, it would be completely opposite right now. I conveniently flipped the data so that they made sense on the PC. This is my big understanding that if I ever want to use to improve this and use it for emulation, maybe try to branch RetroArts Opera. I had that in mind. I tried to slowly re-implement the CEL Renderer. This might be wrong because first of all, I did the test. Let's go draw points for the stars. Now this is a 16-bit. I'm gonna do it another way. If I say now, because it stars, 16-bit is FFFF. Okay, maybe it's 7FFFF, or you can do it because it's 15-bit, and it's very close. So both of them, even if the bytes, if this is flipped with that, it would be the same. Now I could use make RGB. I could use it might be opposite. It might work the same. It's better to do something. I'll show you. I'm gonna do DST plus offset. Cast it. This is pointing to the base, to the first byte. I want you to render only the first byte. Maybe put this. Oh, we have blue stars. And then hopefully it's okay. Let's run 40 also that it runs a bit faster. Overclocked. Oh, what the hell? Why do I have orange stars? But everything else is okay? Something I didn't realize. That shouldn't happen. I'm looking at the first byte in a 16-bit pixel and I write the first byte. This should be the same. The emulation should be the same. Because of endianess, the first byte is like he and the second byte like is like how did I understood that? Okay, or if you say make RGB, if you say R then G I realized this. If you were to read the bytes, now I thought it would be like that. RRR. These are 6 GG, and then the other byte GGG, BBBB. But I think on the three on let me think. The big endian, the way I imagine it when I'm working with pixels is like that, but in reality on the PC, it's gonna be that. So now, if I write the 255 value, the 255 on the PC, because of little endians, it will be like that: 1111 0000. On the 3DO, it's gonna because of big endians, it's gonna be that. So on the PC, I'm writing the first byte. Actually, it's the opposite. On the no, but the real graphics representation is always like this. So on the PC, now this is the orange, this is the blue with a bit of green. It might be the opposite. No, the endianness is like that. So when on the PC you write 255, the first byte. But the PC representation on the PC, if you want blue, blue is low. Okay, on the PC it's gonna be that. This is on the PC. This is on the 3DO. Now, the graphics representation will be that, but on the PC, you're gonna. It confuses me. I realize that now. That's why you're gonna get more blue, a bit of green on the 3D red, and a bit of green, so you get the orange. Actually, here. This is important, and I will tell you something. I never thought that very hard. I always, when I was working with pixels and I was doing okay R24 on the PC, whenever I was doing something like that, even if I knew about endianness, in my mind, it was always I was packing the channels left to right, big endian. The way I was imagining pixels on the PC was big endian. In reality, on PC, if I was to write first byte, it would be blue. So if I did the same on the PC, I would be writing this, but in my mind, I would be mistaken. I would think I'm writing here. Why is that? I know about endianness, but whenever 99% whenever I work with pixels, I visualized the channels left to right in a big endian manner. And I never thought about endianness. So I could come one day and do this on the PC and be surprised on the PC like, whoa, why am I not changing the alpha channel and I'm changing the blue channel? What's going on? But it's true. Because I wasn't used to. I know about endianness, but when you work with pixel, you don't think about it. And I realized something now. Let's restore that. I realized that normally, visually, we get what we will see on the 3DO. But if you read byte by byte the video RAM, it's flipped. It's wrong. For emulation, purposes, this whole thing is wrong. And for emulation purposes, and I might do it in another project, in a Client project, I have to go here where I'm rendering the video RAM. I even have the VDL maps. The correct thing, maybe, is to read this. This is the 3DO video RAM. The correct thing could be or maybe there might be other approaches. I could also flip those. But this is breaking everything. I thought about that. And the correct thing would be to go, for example, here and no, in all the places. I have to go to the 16-bit value and say no, you are not going to. This data must be as they come. These are the original data on the 3DO. You should not flip them. And in CEL utils, you should be, you know what? Nope. You don't do that for the part. You get the data as they come. Now, see, some things are not working. This thing is working. And I realize, okay, things are still not working because maybe I'm creating the color. Maybe I have to. Now that's not how I should do it. And it's still not working. Maybe I have to do. I realize it wasn't easy and I have to redesign from the beginning. Or start from scratch carefully. Maybe when I get the color here, or when I read the source, maybe the color. But I'm not gonna do it like that. I have to study it. Now it's different. Do you know what I mean? Maybe that's also not the correct. How about the VDL maps? But this thing, oh, I need to think. It might not be even that. It might be here. When I render, my rendering might be. Now, if you read the source texture and you don't flip it, what you get, you just write it like this. I think it should be because you read the whatever value. You didn't flip. with the whatever par with. In short, this needs work. Now, for a port, I messed it up. For a port, if I only care about the port, for a port that's okay. If I only care about the port. And I don't care for but if I ever decide to improve the port 3DO base or even some other, I could start another one. I could make some unit tests, not exactly unit tests, but several, like this one, several texts, a sprite in 1 bit, 2 bit, 4 bit, 8 bit, whatever. I wonder if I could screen grab the video RAM data the way they appear on the 3D, or maybe save them in memory or in the some storage and read it on PC, and I have an exact replica. I can even also do it on the emulator maybe. But maybe on 3DO, an exact replica of the bytes of the data, and I can make comparisons, how close it is, and I can make various tests. That's the idea. Now that needs a lot of work. So yeah, to my disappointment, I realized, okay, that's good for porting, but what you see is correct, but it's the bytes flipped. It's not good for emulation. If I ever decide, I had this thought that I could, we talked about Opera RetroArch, that maybe I could try to replace I could contribute, try to replace the CEL Renderer with something. But that's gonna be a huge work. But I realize now that the thing I'm doing is not even gonna be correct. Unless I preserve the exact data, the endianess, and not. And that's it, guys. I'm doing some work with that. I don't know. Maybe I can fix few things, but I might. It's a big work, and I might going to go back to Bizarro. I might going to continue with Bizarro or do other things, but I was doing this because it was relatively easy to slowly fix things, run the experiment and try to fix them. Maybe I'll fix few more, but that's it. And I guess that's it. It's been a long video, so I'm not gonna pretend I wanted to do a short one. So bye.